Okay, very good. I'm Diego Salsa, and before I start the technical part of the training, I'll introduce these 3 days of training. So we saw previously the part regarding business proposal and solution, and now we start with the technical part of the course. So that means the installation use of the web manager platform. First, we will start with a description in deep with the logic of the stacking. So our solution, how it works, and how we will see next in the other parts of the. We'll finish today with a description on how to build the map of the site in order to what we see before with Andrea. And for tomorrow, we will talk about the technical installation of the platform and of the elements that constitute, so Docker, VPN, and so on, and the site configuration. The last day, we will see the installation of all devices, the configuration of devices, and a description on how use and work the web manager with all functionalities, especially referred to the sTrack LTS solution, and a little view of the system administration of the web manager. At the end, question and answer. But if you have any other question today or tomorrow, no problem. We can reply quickly. Okay. I think that is now for this presentation. Franco will start with the description of the logic of the stacking.
I share my screen. Can you see the screen?
Yes, Franco.
Okay. Good morning, everybody. My name is Franco Serio. I am the CTO of Reios, and I want to discuss today about the system architecture of the sTrack functionality of the Reios platform. Before Massimo and Andrea spoke with the wearable, the S-Tag, the QStat, etc. Now I want to start from these components to create the infrastructure that is necessary to track, to make the tracing of people and asset. So what are the components? First of all, the S-Tag and the QStat. Massimo said before, the S-Tag is a basic one. The QStat is also for health functionality. A small device that transmits a Bluetooth beacon with a unique identifier. So you can see this sending constantly information that can be used later on to make the tracing. There is some Bleo server that we call the S-Gate that is a stationary device and is capable to listen to the beacon and measure the RSSI. We can see later on how we can use this type of information. In order to send this type of information to a central part of the system, it's necessary to have a Wi-Fi network. It's a 2.4 gigahertz Wi-Fi network. And of course, if it's possible to use the Rajant breadcrumb Wi-Fi, it's the best solution. Otherwise, the customer can have already installed Wi-Fi and wants to use the Wi-Fi. Of course, if the Wi-Fi installed is a breadcrumb, is much better. we have something that can help us to transform the RSSI, the quality of the signal into a distance. More are you far away from one gateway, lower will be the RSSI. When we have all this type of information, we can collect this information on an edge server. Is not in the cloud, but typically is the LAN. But if you want, you can also put it on the cloud. And there are some special software capable to calculate the position, and some other tool capable to show the position of the asset or people into a map. So this type of display can help you to see the position of the people, and later on also to have some possibility to verify what happened in the day or in a month. The edge server can be hosted by a cowbell platform. So if we want to combine together the Rajant solution and the Reios solution using the cowbell, it's a great idea, because later on you can use all the cowbell platform functionality to improve and to add a new type of feature. Now, let me describe the algorithm that we are using to collect to calculate the distance. So we are using the trilateration process. What is saying the triangulation process? We have the distance between the gateway that are the S gateway. You can read L1, L2, L3 are where the gateway is stationary, and we know exactly the geographical geo-reference position of the gateway. And there is a wearable moving. This is the point P. Now, the distance between S gate and the S tag are calculating using the RSSI, as I said before. It is a received signal strength indicator, as they are inversely proportional. So if, as I said, if you have a very low RSSI, the distance is higher. So when you have RSSI, you can calculate the distance. So the S gate has a defined position X, Y, Z in a georeference sitemap. So moving, adding this type of position, we can find exactly the position of the map. There are three circles, these three distance, and the point that you can intersect is used to determine the position of the tag. This is the formula, okay, that we use in our software, and so we can to be precise on the position. But what is the real life? The real life is that the RSSI is moving, is not a constant situation. So if you have one tag in a position and you don't move it, theoretically you use the same, you read the same distance, the same RSSI. But due to the environment, this RSSI can create some variation caused by reflection barrier present in the environment. And this intersection, this variation, make possible that all the circle that we described before are not intersect. And so in this case, we need to introduce a new algorithm, and this is the value of the Reios algorithm, to assign, to calculate the position. And so we have in our software, they assign weight to the observer based on proximity. So the closer the observer is to the wearable device, the stronger is the weight that determines the fine position. These are three examples where you see that one wearable is not perfectly intercepted by the circle. So to make more precise, we have the possibility to define a custom RSSI to distance table to better estimate the distance. So we can add this table in this way. So if you have the RSSI minus 30, you know that the distance is 0.5 meters. If you have minus 40, you know that is 1 meter. So at this level, each device can, reading just the RSSI of the wearable, can determine the distance. The accuracy range is typically 1 to 5 meter. It can be better. Okay, and what are the factors that can influence the accuracy? One is the grid of the gateway intercepting the sTrack beacon. The denser the grid, the more precise the position will be. So when Andrea described before how to put the S-gate on the map, of course, if you reduce the number of S-gate, you reduce the accuracy. But this is important because there are some customer who wants to have 10 meters, should be enough because they want to know more or less where the people are. And so we can reduce dramatically the number of the S-gate. The accuracy can be precise also due to the RSSI fluctuation due to walls, furniture, etc. There are also signal multipath effect and environmental connection. So all these events can reduce the accuracy of the RTLS position. Now we can see how is the data flow and how the system work. Suppose that if you want to know what is the sTrack is doing, is very simple. The sTrack is emit data beacons every 660 milliseconds. In this beacon, this is an example of infrastructure. So if you read, is send using the BLE is sending a packet of 30 bytes, and this is the formatting that you can see on the right of this infrastructure. But formally, what is important is that the wearable is sending temperature, humidity, pressure, and battery status. So you can use this for the asset tracking, asset or people tracking, but also you can use it for the environmental condition and to generate alarm if the temperature is too high or the humidity of the pressure, and of course for the battery status. This beacon is a beacon in broadcast. So there are many observers listen to this message. Each observer will add some information. The RSSI, that is a very important point. The S-gate is capable to understand the RSSI of the wearable. So how far is in other words, how far is the wearable from the observer? Each observer will send this type of information to the S server, and will use the NMQTT broker that is running over an IP network. So typically the BLE server is capable to convert the BLE protocol into a Wi-Fi MQTT S-gate protocol. So this will be very simple. You can see later on. Work with this type of information. All data are JSON message. It's very easy to read this type of data, and the broker works with the publish and subscribe message. So the observer is publishing the message, and on the other side, more than one client can subscribe this message and handle this message. So when the broker receive the publish of the MQTT, there is a position calculation process that is working, subscribing this type of message. So the position calculation process use multiple S-gate to determine the distance. So we saw before the trilateration process. The trilateration process work with the intersection of a circle. And in this case, the position calculation process receiving from 3 or more Bleo server can calculate the position. When the position is calculated, this we put again on the broker the position of the sensor. So we receive just data, multiple data from one S-gate. In this case, the position calculation process is capable to determine the distance and publish the distance. The position of the sensor. Adding, of course, the tag ID, the timestamp, and the floor, the site, and so on and so forth. When the position message is published, there is another process that we call Web Manager that is capable to display the stack position on the map and enable position-based control. The system can detect asset violation in a restricted area or handle mastering area emergency using different colors for a stack on the map. You can see in these days how we can define this type of information. This type of publish make easier for third party to create a new type of application. So if your customer is asking you to have a special dashboard, you can ask us to put this service inside the web manager, or if you prefer, you can have a third-party location-based application, adding some special software already existing in the site. So it's easy to, for instance, to integrate some RFID technology with this BLE technology because you can combine the two using the position that we can calculate. So the position can be based not just on our web manager, but also on third-party application. There is also another possibility when you don't have the Wi-Fi network to reach the site, you can use LTE gateways. So they work on one side, they are capable to receive information from the beacons, the beaconing done by the standard wearable. So the wearable is not different if you have an S-gate LTE or if you have a normal S-gate Wi-Fi. And inside the LTE, there is the possibility to convert the message, the BLE message, into an MQTT that use the LTE. When you reach the broker, of course, the broker should be in one part of the broker should be in a public area because the LTEs work with a public area. And the process will be exactly the same of the previous one. So it's possible also to combine. You can have normal S-gate where you have the Wi-Fi coverage, and you can have S-gate with LTE if you want to extend the coverage where the Wi-Fi is not reaching. So the conclusion, the solution is designed to monitor the position of people and assets. Real-time location system enable the tracking of people or objects in a physical environment but using BLE wireless technology. The BLE wearable device transmit beacon at a regular interval. The S-Gate BLE server are connected to the VLAN via Rajant breadcrumb Wi-Fi or an existing Wi-Fi. The RSSI measurement are observed by the observer, the S-Gate, and measure the signal strength of the beacon advertised to estimate the distance. The S-Gate is capable to convert the BLE beacon into JSON message, which are sent to the server MQTT broker via MQTT client. The position estimation process uses trilateration, and there is a web manager capable to handling the position process. There is another opportunity to create a tracker, the tracing functionality, and is the LoRaWAN. So in this case, we have the LoRaWAN tracker that are capable to emit directly the GPS position. So these are done using a LoRaWAN network. The LoRaWAN can be very large, suppose 5 square kilometers with one gateway. The protocol, the LoRaWAN is a low power network, and so you can use this tracker for a huge number of position communication. You receive a LoRaWAN gateway. We have the possibility to combine LoRa gateway and LoRa network server. We intercept a signal coming from the LoRaWAN, and we put outside using the MQTT publish. Using one process to convert the GPS positioning into X, Y, Z, we can look this gateway as a normal gateway. Look this asset tracker or wearable as a normal S-Tag or QSTAD. This is a very simple solution of LoRa. As you can see, we have just some LoRaWAN tracker. We have one or two gateway. And when you receive what you saw before for the BLE will be available through the GPS XY converter. So in conclusion, the Reios sTrack solution displays the steps position on the map and enable position-based control. It's capable to utilize different type of BLE and different type of measurement based on trilateration in case of BLE, based on GPS in case of LoRaWAN network. The accuracy depends on the grid of gateway intercepting the S-Tag beacon. The denser the grid, the more precise the position will be, and precise calibration of RSSI to distance mapping and environment factor. Tomorrow we see how to define this type of map. So I'm finished. If there are some questions. Okay, so we can proceed with the ArcGis part where we can explain how to create a map for the system to show to allow the display of this type of information on a map. Please, Diego.
Thank you, Franco. Now we can start with the last part of today. That is the description of the preparation of the map that will be uploaded to the Web Manager platform. All the functions implemented in the Web Manager required the application of the georeferences of the map to identify the correct position, both of fixed as gateways and mobile devices, wearable, for example. in order to reach the target of the specification and requirement described that we saw before in the description of the solution deployment of Andrea. To start with this activity, we need to define, to have first the application of ArcGis Pro that is a software, professional software with a license that include the definition of the world map in order to refer every map of the site that we needed. The other point is to have the map in a format DWG or DXF, normally come from the final user, because describe the details of the site map, included external and internal area, included different floor, and everything needed to define the environment where we apply our system. Could be necessary sometimes AutoCAD or similar to the software for adjusting the drawing in order to reach all the information necessary for the project. The map needed to contain correct coordinates of the geographical space. Normally is not present, but is present is better, because we will see later that the map will be put in the correct position in the worldwide map. Obviously, the map need to have a correct dimension in order to the correct scale, and include a layer containing walls, fixtures, everything is interesting for the development of the project. We need another point, the location coordinate. So we need to be sure where is the location of the site. So in order to fix the correct coordinates in the web manager. So the other point is to have a view of the project design, what Andrea describes before. So we need to define the layout where it works, the system, define the destination views of each area and how each area are divided. Define restriction areas or area where it is forbidden to move. Define the position and the orientation of each device will be put inside. Starting from these requirements, we can start to have a look at how to create the map. So this is the first, the open page of ArcGis Pro, where we can start to create a new project on critical map. So we have to give a name of this project and to the location where is saved the final file. First point is to upload the map. The map is what we said before, need a DXF or DWG file coming normally from a final user that describe all the details of the site. We saw before that the map could be geolocalized. In the left side of the screen, you can see an example of the correct location. So when we open, we upload the map is on the correct position on the worldwide map. On the contrary, the map will be put in the default location that is 00, Equator and Greenwich. And from this point, we have to move to the correct position. To move in the correct position, we open a georeference coordinated. So in this way, we can change and we can update the geographic coordinate of the drawing. We can use the three main elements for the modification. So move to the position, scale to adapt the scale of the site of the map, and rotate to orientate in the correct direction. This is an example of a map after the modification put in the correct and definitive position. Now, next point is to add all the information on the map in order to prepare for the uploading to the web manager system. So, first of all, we have to create a layer where will we build the polygons. Polygons are, we can see an example here. This is polygons on this example site. Polygons define specific area where events happen. Each area could have a different way of use, different destination, different, for example, restriction for the access, or different way to manage sensor for temperature, for humidity, for everything needed to control inside the site. For example, a typical area is the boostering area, where the people collect in case of emergency. But it could be used for critical size, for white room, for everything needed to identify a special kind of use of the area. So what we have to do, I come back, is to start creating. So we have to define, first of all, the basic layer where to build the polygons, and this layer has to be called array, is the only accepted name. Then we have to fix another main layer that is the shape, the walls of the site, and these are the layers that will be moved, we will upload in the last phase on the web manager. Now we start to define the polygons. The polygons are built, we said, in the array layer. So we start to build step by step all the area, the definition of the area, in order to what see in the preliminary project that we see before with Andrea. And last step is to define the specification of each single area. It means the name, it means all the properties needed to be shown in the web manager. We see an example of all the properties that we needed to change in order to show everything. This is an example of some polygons, some area defined with name, specific name, and with the label that can show it. This is important because in this way we are looking now, we will see in the web manager. Here, for each this area, we will put later in the web manager all the devices linked on the area, or define restriction. For example, a wearable tag with a person could be forbidden to go inside this office, so there is an alarm. Or there is a mastering area that could be, for example, in this whole area, and all the people will be counted when they are inside to check for emergency. Once finished the definition of all area, we have to prepare the map for the sharing, for the uploading to the web manager. So we need to publish. So we define the name of the map, normally linked to the name of the project, and we create the web publishing. When published, we open to have a check the ArcGis Online that can show how the map will show. And we have another point very important, that is this one in red circle, that is the URL. So the address where is loaded the map, and where we have to address the web manager to reach the map. This is how the map will show in the web manager. This is an anticipation on what we will do in the next phase in the site configuration. So we need to define the correct position and the correct orientation of the map of the site in the worldwide map. So we have to copy in these three positions, the blue position, longitude, latitude, and the angle of orientation. Now we see where we can have this information. For example, for this site, we decided that this is the 0 point. Sorry. That this is the 0 point. So the 0 point has this coordinate. Coordinate west, coordinate north in decimal degrees. And the same, we can calculate the rotation, so the angle that we need to define in the web manager. For example, in this case, is 20 degrees. There is an argumentation of the sign of these numbers. So the convention is north and east direction, the number is positive. South and west direction is a negative. Same for rotation, clockwise is positive. This is the last page of the configuration, where we will use our information that we find in the ArcGis software. Is the URL that we saw before, and this one. This address we can copy from it and put in this position layer. That means that the web manager address to this URL to download and update the map and show on the web manager how is all the position, all the polygons we defined, and we can start at this point to put inside everything is necessary to define the site configuration and the device configuration. This is all for a quick description. Now we can have some small example of this is ArcGis position. You can see that here in ArcGis we can see the worldwide map. For example, we had defined an example drawing of the map. This is as our office here in Novara, in Italy. So we can see the map. Here we have the map of the office with the walls, perimeters, and features of the. What we can do with this, for example, we can, when we said before, we can open the georeference modification. And what we said, we described before, for example, we can move the map. It is necessary. We can scale it, for example, for this. Or we can rotate. So we can do everything is necessary to adapt the position of the side map in the save. Okay. Sorry, my PC is okay. Now we can give an example to how to prepare the polygons here. So we said before, catalog pane, database. This is the project. Feature class, and here we define the name of the layer. Are is a fixed name of the layer. We can save. Okay, and now we see here. We put in the first position. This is the layer where we could prepare the polygons. So we go, for example, to the create new. So fixing an area. We define. For example, here we have the snap, so it's easier to fix the shape of the layer. For example. Okay. Then we can define the properties of the properties normally means especially the name, because it's how to recognize the polygons, the area, in the web manager later when we define the configuration of the site. Everything. So we define name. So we give name to this one, office 2. Office 2. Okay. Now we show it. We have to do some small modification to. Okay. Sorry. Okay. We do some small process to be sure that everything. Okay. Now we define the name of the layer. Now we can go on to define everything else that needed to identify the reason of the project. So, for example, define mastering area, define everything. It's important for the project, and then we can share with to the cloud in order to upload this map to the web manager. That's all. Tomorrow we can start. We can with site configuration, where we will start using this map in order to define all the elements that define the base of the project.